pag-usapan natin ngayong araw ang entropy. No? Bakit? Yun siguro unang sasabihin niya. Bakit? Kasi ang hirap-hirap na nga sir ng first law of thermodynamics eh. Ang hirap na nga ng internal energy. Ang hirap na ng enthalpy. Ba't mo pa dadagdagan? Ito kasi yung problem. No? Kasi ang scientist, no, kunwari gagawa ka ng mga chemical reaction, chemist ka kunwari, kailangan yung pag pinaghalo-halo mo yung chemicals mo, dapat alam mo, magpo-produce yun ng products. Okay? Kasi kung pinaghalo-halo mo yun, tapos walang nangyari, sayang, di ba? Okay. Kunwari, gagawa ka ng gamot, no? Okay. In making medicinal drugs, kailangan you should know that your reactants must react talaga, no? Kailangan may mangyari talaga sa kanila. Otherwise, sayang yung pera mo. Sayang yung pambili mo ng chemicals. Okay? So, ibig sabihin nun, ang next question sa mga scientists before is, paano ko malalaman if a reaction will happen? Okay. Yun yung question nila. Paano ko malalaman kung mangyayari yung isang chemical reaction? Okay. Ayan, paano nga ba? So, isa sa mga way to answer that is by using the energies of the chemicals. No? By determining their energies, no, you can determine kung mangyayari yung reactions or not. Okay? Pero ano ba yung energy na meron tayo? We have internal energy and enthalpy. Let's focus on enthalpy kasi yun yung experimentally determined. Okay? So mag-focus muna tayo sa enthalpy. Okay? So, yung enthalpy ba, pwede ba niya masabi kung ang reaction ay mangyayari o hindi? Tignan natin. Okay. So, for example, if we combust methane, ang enthalpy nun ay negative. Ibig sabihin, exothermic siya. So, nangyayari yon in nature. Papel, sunugin mo, exothermic yon. So, it happens naturally. However, there are also processes, okay, or there are changes which has a positive delta H value pero nangyayari pa rin. Okay? For example, yung tubig from solid magiging liquid, no? Yung melting ng water. That is endothermic process. Pero, nangyayari siya. Okay? So, ibig sabihin, enthalpy cannot be used to determine whether a reaction will happen or not. Okay? Kasi ang sinasabi lang ng enthalpy ay yung heat transfer. So, hindi porket negative yung delta H ay mangyayari yung reaction. Hindi porket positive yung delta H ay hindi mangyayari yung reaction. Okay? So, ang idea dito is that, ang idea is, yung sign ng delta H, hindi niya masasabi kung mangyayari yung reaction or not. Because some reactions are endothermic, pero nangyayari yon. Some reactions are exothermic, pero nangyayari din. Okay? So, ibig sabihin, the sign of delta H is not enough for us to determine whether a reaction is spontaneous or not. So ngayon, naglapag na ako ng term spontaneous. Ano ba meaning kapag spontaneous? Ibig sabihin ng spontaneous is that it is a reaction that will occur naturally. Okay? So natural yung occurrence niya. Basta mangyayari yung chemical reaction. If that happens, then it is a spontaneous process. Okay? So pag nangyari na lang bigla, spontaneous yon. Okay? For example, yung baso, bitawan mo, nabasag siya. Spontaneous yon. Okay? Pero ang tanong doon, anong gagamitin mo to determine spontaneity? We just discovered na yung delta H hindi pwede gamitin for spontaneity. Kasi nga, yung signs ng delta H, it doesn't really tell whether spontaneous yan or not. No? So, hindi niya sasabihin kung, ito, pag negative, spontaneous. Pag positive, spontaneous. Wala. Kasi, observe tong dalawang to, no? Nangyayari to sa paligid. They are both spontaneous, pero yung signs ay magkakaiba. So, ibig sabihin, there is now a need to define another energy term. Okay? So, yun yung motivation nila. Hindi kasi nila malaman ano yung spontaneous process. Kaya, gumawa na naman sila ng panibagong energy form. Okay? So, that energy is called the entropy. Okay? Ano ba yung pumapasok sa isip pag entropy? Ito, mga nasa meme to sa Facebook, di ba? Pag sinabing entropy, ano iniisip nyo pag ganun? Ano yung naaalala nyong idea pag entropy? Pag sinabing entropy, usually sinasabi nila disorder, di ba? Yung pagkakagulo ng system, no? Okay? So, totoo yun. Tama yun. So, entropy is actually the measure of how energy is spread out, no? Or dispersed in the system. Okay? So, when you say yung energy ay spread out, basically, yung energy mo, kinakalat mo. The particles are spread out, no? No, ibig sabihin, pag makalat, mataas ang entropy. Okay? For example, yung nips, no? M&M, nasa loob ng sachet. Pag yun nabutas, kakalat yung M&Ms, no? Kakalat yun sa sahig. So, ano yung mas entropic? Yung nasa loob ng plastic o yung kumalat sa sahig? Ano mas makalat doon? Ano yung mas entropic? Yung kumalat sa sahig o yung nasa loob yung plastic yung mga nips? Ano yung mas entropic doon? Dali, any idea? Ano sagot doon? Ang sagot doon ay yung nips kapag kumalat sa sahig, yun yung mas mataas ang entropy. Kasi sinasabi ng entropy, siya yung measure ng disorder. No? So, ibig sabihin, kapag ang particles mo ay kalat-kalat, ibig sabihin, mataas entropy nun. Okay? If your energy is dispersed, ibig sabihin, mataas yung entropy nun. Okay? So, yun yung idea ng entropy. And this can actually give us an idea kung kailan ang reaction ay spontaneous o hindi. Okay? So let's take a look at these two classic examples. For example, dito sa letter A, you have particles dito sa left, sa right, wala. Pag binuksan mo yan, pag binuksan mo yung takip na yan, alam natin, yung particles na yan kakalat. But would you expect na yung kalat na particles ay babalik sa original? Maasahan mo ba yun na mangyayari? Hindi, di ba? Ibig sabihin, by determining the entropy, you can tell whether a reaction is spontaneous. Okay? If the system spreads out, ibig sabihin nun, pwedeng spontaneous siya. Okay? Pag yung energy kumalat, na spontaneous yon. Kaya ibig sabihin, kunwari, yung baso, pag nahulog yan sa sahig, pag kumalat yun, di ba, magiging glass fragments yon. Yung mga shards ng glass, no, yung mga fragment, yung mga basag-basag, kakalat talaga yun sa paligid. Kasi yun yung sabi ng entropy, no. Ang gagawin ng entropy is to disperse the energy, to disperse the particles, no. Ibig sabihin, pag nabasag yung plato, yung baso, kumakalat yun. Kasi nga, favored yun ng entropy. Mangyayari kasi talaga yun. Okay? O kunwari, meron kang bag ng nips, o kaya mga M&Ms, o kaya mga Hershey's, no? Pag nasira yung container nun, kakalat yun, no? Kakalat yung mga pagkain na yun sa kung saan. Kaya yung pagkalat na yun ay spontaneous kasi entropic yun eh. Yun yung direction eh. Always papunta sa disorder ang universe, no? Okay? So yun. So that means entropy can be used to determine whether a reaction or a process is spontaneous or not, no? The general idea lang is that kailangan positive ang entropy para maging spontaneous ang process. No? Kapag mas kumakalat yung particles, mas spontaneous yun. Otherwise, hindi pwede yun. Okay? Kaya nga sabi nila sa physics, no, yung iilan, no, sabi nila is that entropy is somehow the arrow of time, no? This is somehow considered the arrow of time, no? So it tells us na always forward lang, walang pabalik. Kaya nga ang ano nila, ang kanilang argument for time machine or for time travels, you can travel ahead of time, but you cannot go back sa time. Okay? Kasi yun yung sabi ng entropy. Always going to disorder. Always forward. Never magba-backward yung process. Okay? So, yun yung idea ni entropy. Okay? Hindi ka pwede bumalik sa 1970s kasi andito na tayo sa 2021, no? Wala tayong magagawa. Dire-diretso talaga 'to, no? Yun yung pwedeng idea na ibigay sa atin ni entropy. That always everything goes to disorder. Okay? And whenever disorder happens, spontaneous processes happens, no? Okay? So yun yung idea ng entropy. Kunwari na lang, nagpabango ka. 'Di ba kumakalat sa hangin yung pabango? And never yon na magstay lang siya doon. Nag-spray ka, andun lang siya. May pocket lang doon ng hangin. Hindi ganoon, 'di ba? Kumakalat yung yung fragrance sa hangin, 'di ba? Kasi nga mas nagiging disordered kapag kumakalat yung particles, no? So, yun yung idea ng entropy. Okay. So the concept of entropy was established, no? Was flourished by a man named Boltzmann. Okay, so si Johann Wolfgang Boltzmann, yun ata pangalan niya. Okay, so yan si Boltzmann. So isa sa mga physicist na inahangaan during his time kasi ang laki ng contribution niya. Although apparently nag-suicide siya kasi may mga bagay siyang hindi ma-explain sa physics, no. So yun lang naging reason niya to do that, no. Pero big deal kasi yun that time, no. Kasi isa siya sa mga tinitingalang tao sa larangan ng agham. Yan. So anyway, so before Boltzmann died, no, ang nangyari is malaki yung contribution niya in understanding the entropy, no. So according to him, the entropy can be measured using the equation K ln W, wherein K is the Boltzmann constant and W is the microstates, no. Ano yung microstates? Okay. Yung microstates, yun yung probability of occurrence of a particular distribution depending on the number of ways, no. In Tagalog, ang meaning ng microstates ay ganito. Ito yung probability na pwede mo ikalat yung particles mo. Okay? So, the more spread out yung particles mo, ibig sabihin, mas malaki yung probability na sila ay distributed. Okay? So, mas malaki yung probability na sila ay distributed. No? Pag mas makalat yung particles mo. So, ibig sabihin, using the equation, if we have high microstates, then that means we have high entropy values. Okay. Pag mas makalat yung particles mo, sabihin mas malaki yung probability distribution niya. As a result, malaki yung entropy niya. Pero kapag maliit yung inyong distribution, confined lang yung particles mo, mababa yung entropy mo. Okay? And also, they defined entropy as a state function, meaning you cannot really solve for this, rather you can solve for the changes. Okay, so you can solve for the changes because it is state function. Okay, so that means S cannot really be determined simply. Okay, so it has to be calculated. No, okay, so delta S is SF minus SI. Okay, so again, mapapansin nyo, every time we have state function, naka-delta siya parate. Ibig sabihin yung delta U ay state function, delta H ay state function, and delta S ay state function then. Okay? So yun lang yung idea. So by determining the changes in the microstates of the system, you can measure the entropy changes. Okay? Pag mas malaki yung final microstate kaysa sa initial microstate, ibig sabihin kumalat yung particles mo, positive yung entropy change mo. As a result, spontaneous yun. Pero kapag mas maliit yung final microstate kaysa sa initial microstate mo, mababa yung entropy mo. Negative siya in value. Okay? So, yun lang idea ng microstates and entropy. Ang idea lang is, kapag kinalat mo yung particles mo, mataas entropy mo. Pag hindi mo siya kinalat, ibig sabihin, mababa entropy mo. Okay? As a result, hindi spontaneous yung process. Okay? So let's take a look at some examples here. I want you to tell me whether positive or negative ang entropy change dito. Okay? So by just looking at these diagrams, kailangan ma-predict natin yung entropy changes. Ano uli yung general idea? Pag makalat yung particles, positive ang entropy. Pag hindi makalat, negative ang entropy. Now, how about this one? Letter A. Solid to liquid. What is the entropy change? Positive or negative? Now, ano entropy change dito? Positive, negative? Again, kapag positive, kumakalat yung particles. Pag negative, hindi kumakalat yung particles. Ayan, by just observing this, ano yung ating sign for delta S? Dali, you can use your mic para tayo, para interactive tayo. For letter A, is this positive in entropy o negative in entropy? Madali.
Positive.
Positive. Bakit siya naging positive? Kasi
kumalat po.
Kumalat yung particles, no? From confined, no? From dikit-dikit, ngayon, spread out na siya. Okay? So, positive ang entropy dito. As long as na-spread out yung particles mo, that means you are increasing the microstates, no? So, as you increase the microstates, therefore, positive ang entropy mo. How about letter B? Well, for letter B, ito. Liquid to vapor. Nawala. Ayan. Letter B, liquid to vapor.
Positive po.
Yan ay? Positive, negative. Positive pa rin, no? Okay. So, positive yan. Bakit? Kasi yung particles mo, nag-spread out uli. So, as long as nag-spread out yung particles mo, positive ang entropy dyan. How about letter C? For letter C, that is also positive yan, no? Okay. Siguro mahina connection. Pero anyway, so positive ang sa letter C. Kasi napansin mo, yung green particles, dikit-dikit sila originally, ngayon kalat-kalat na sila. Okay? So ibig sabihin, may disorder. Ibig sabihin, mataas yung entropy. Positive yung entropy. And for the last one, ito, from system at temperature 1 and system at temperature 2, wherein temperature 2 is greater than initial temperature, ano kaya sign dito? For the last one. Mas malaki daw temperature nito kaysa dito. Ang delta SI, sagot ay positive pa rin, no? Positive pa rin yung delta S dito. Kasi, bakit? Kasi, pag mataas yung temperature, remember, yung particles natin, mas malikot. Okay? Mas naggagalaw-galaw sila. And since mas gumagalaw sila, mas malaki yung disorder nila. Okay? So, kapag mas mainit, mas disordered ang particles. Therefore, mataas ang entropy. Okay? So, yun yung idea. So, by just looking at the states of the system, you can actually tell whether positive or negative ang iyong um, entropy changes. Okay? So, to summarize, we can say that the more particles produced, the greater the microstates. As a result, mataas ang entropy. And if you increase the temperature, the entropy increases as well. Bakit? Due to additional energy for the particles to move. Mas gumagalaw yung particles pag mas mainit, kaya yun, mataas yung entropy. Ito, another examples tayo. Now, I want you to determine the entropy changes. Sabihin nyo kung positive o negative depending on the statements. Okay? Tulungan nyo ako para mabilis tayo. Freezing ethanol, positive or negative yung entropy? Positive, negative, tapos bakit? When you freeze ethanol, ano ba nangyayari sa freezing? 'Di ba, yung liquids nagiging solid. Remember yung diagram natin ng particles. 'Di ba kapag liquid, kalat-kalat sila. Kapag solid, dikit-dikit na sila. Okay? So ano nangyari doon? Positive ba or negative yung entropy doon? Yung liquid separate yung particles, yung solid magkakatabi. So ano yung entropy doon? Positive o negative? Ang entropy doon ay, andali, hula kayo, okay lang. Sagot. Yun ay negative. Sinabi ko na sagot ha. So, negative ang entropy when you freeze ethanol. Bakit? Kasi yung particles mo, pag liquid, hiwa-hiwalay yan eh. Pag yan naging solid, magdidikit yan. So, lumiit yung distances nila. Therefore, lumiit yung microstates. No? Kapag yung microstates lumiliit, usually yung distance ay lumiliit din. So as a result, ito ay may negative entropy change kasi yung particles mo nagdidikit-dikit. Okay? So nagiging ordered sila. Hindi sila nagiging disordered. Ordered. Okay? So for letter A, sagot is negative. For letter B, evaporating beaker of liquid bromine at room temperature. Ano to? Is this positive, negative? Madali. Kayo naman. Positive or negative ang entropy change? Any hula? Dali guys, para ano? Para tuloy-tuloy tayo.
Positive.
Positive. Bakit? Kasi positive yan kasi ano ba nangyayari kapag evaporation? Yung evaporation, liquid to gas yan, di ba? So, yung liquid, ito yung particles mo. Katabi lang. Pero kapag gas yan, ano ginagawa mo sa particles mo? Kinakalat mo yon, di ba? Nag-spread out lalo yung distance nila. So, since mas makalat na yung particles natin, mas spread out siya, ibig sabihin, positive ang entropy dito. Okay? So, pag nagkakaroon ng evaporation, positive ang entropy. About this one, dissolving glucose in water. Pag tinunaw mo daw yung asukal sa tubig, ano yung ano? Ano entropy nun? Positive, negative? Dali, okay lang manghula, Les.
Positive po.
Positive pa rin. Ayun. Tama. Kasi, ano ba nangyayari kapag tinutunaw natin yung asukal sa tubig? Di ba from solid, kumakalat yung particles, no? Nag-spread out siya sa solution. Imagine nyo yung iced tea. Pag nagtitimpla kayo ng iced tea, ano nangyayari? Di ba, in solid sa baba, pag hinalo mo yun, kumakalat yun. Okay? So, ganun yung idea. Pag tinunaw mo yung mga solute sa solvent, positive yung entropy. O letter D, cooling nitrogen gas from this to that. So, the entropy change here is again, yung sabi ko kanina, kapag tumataas temperature, tumataas entropy. Ibig sabihin, kapag binababa mo temperature, bumababa ang entropy. Okay? So, this one is negative in entropy. Tutuloy-tuloy ko na para dire-diretso tayo. Okay? Kung may question kayo or may di magets, you just ask, ha? Okay. So, this one is negative for letter E, condensing. This is also negative. Ano ba nangyayari kapag condensation from gas to liquid? Okay? So, ibig sabihin yung magkakahiwalay na particles, pag didikitin mo uli. So, this is negative in entropy. Letter F, forming sucrose crystals. Okay? So, kapag mag-form ka ng crystal, okay, ibig sabihin from ions to solid yan. Okay? So, this is also negative in entropy kasi magsasama-sama yung particles to form the solid. Heating hydrogen gas, no? Sabi ko nga, when you increase the temperature, you increase the entropy kasi mas lalo magiging magalaw yung particles. Subliming dry ice. So, pag sinabing sublimation, solid to gas. Ibig sabihin, mataas yung entropy niyan. Okay? Ito, you are stacking your books into shelves from being scattered across the room. Ito, kayo naman uli. Yung libro nakakalat, tapos aayusin nyo. Ano yung entropy niyan? Positive o negative? Yung makalat na libro, aayusin nyo?
Negative.
Negative. Negative yung entropy niyan. Kasi, yung kalat-kalat na libro, ayusin mo From disorder, gagawin mong ordered, no? So, negative yon. And last one, you and your crush dating. Ito, joke time ko lang to sa mga students ko before. Negative ang entropy nito. Bakit? Magkalayo kayo. Tapos pag nag-date kayo, edi magkasama kayo. So, from disorder, nagiging ordered. So, negative yung entropy niyan. Okay. Tapos ano yung sabi natin? 'Di ba kapag pag negative ang entropy, generally non-spontaneous 'yun, okay? So non-spontaneous process 'yun. Ibig sabihin, ang joke ko diyan sa mga bata ko, kapag kayo may crush kayo na dinedate nyo, hindi favored 'yon ng nature kasi negative ang entropy. Okay? So yun lang yung idea diyan. But ayan, no? By just determining the states of matter, you can tell whether positive or negative ang entropy. Ang basic knowledge lang na kailangan nyo gawin dito is that kapag mas kumalat yung particles, mas positive ang entropy. Pero kapag hindi nakakalat yung particles, negative ang entropy. Okay? The more disordered, the higher the entropy. The more ordered, the lower the entropy. Okay? So, yan. So, with that idea, punta na tayo sa second law of thermodynamics. No? So, ito, we need calculations dito. So, for the second law of thermodynamics, since this is primarily focused on spontaneity and entropy, then we can say that A process, no? A process, no? A process is spontaneous if the entropy is positive. Pero ano yung titignan mo? Okay, kasi ganito sa thermodynamics, sa second law of thermodynamics. Hindi ka lang daw dapat nakafocus sa system. Kailangan nakafocus ka rin sa surroundings, okay? So generally speaking, you are looking at the entropy of the universe, no? Kasi sabi ko nga sa inyo dati, system plus surrounding equals universe. Ang gusto ng entropy, tignan mo lahat as a whole, hindi yung isa lang. Okay? Tignan mo daw kung yung system at yung surroundings ay ano yung entropy values nila. If the entropy of the universe is positive, that means you have spontaneous process. Okay? Universe, take note. Universe yung kailangan mo tignan, hindi yung system lang. Okay? So, anto naman, for equilibrium process, delta S universe is equals to 0. Bakit? Kasi, pag equilibrium, kung ano yung ibibigay ng system, yun din yung ibabalik ng surroundings. So, same value lang, opposite sign. So, pag pinag-add, 0 yun. Okay? So, pero focus tayo dito sa isa. For spontaneous process, delta S universe must be greater than 0 or positive. Okay? Ibig sabihin nun, kahit negative yung delta S mo, delta S ng system, basta positive yun sa surroundings, pwede pa rin maging spontaneous yung process. Okay? Pwede pa rin maging spontaneous yung process. Bakit? Kasi tingnan nyo ha, bakit umuulan kung negative yung delta S nun? Okay. Bakit umuulan? For example, ngayon medyo may patak-patak konti. Kasi 'di ba sabi natin pag condensation negative yung entropy. Pero bakit umuulan? Okay. Kasi nga ganito. Kahit negative yung delta S system mo, basta positive yun sa surroundings, pwede mangyari yung reaction. Pwede mangyari yung chemical process, no? Okay. Ibig sabihin, uulan talaga. Kasi, although negative yun sa system, yung entropy niya, yung sa surroundings, positive kasi. Okay? And vice versa. Okay. Pwedeng negative siya sa surroundings, tas positive sa system. Okay? So, depending kung sino mas malaki, pwede maging positive yung iyong delta S universe. So, ang general idea dito is that hindi pala porket negative yung delta S ay na siya, non-spontaneous na. Alamin mo muna kung ano ba yung negative. Yung sa system ba or yung sa universe? Pag yung sa system yung negative, pwede mo pagawa ng paraan para maging spontaneous yon. Pero kapag yung universe na mismo yung negative yung delta S, hindi mangyayari yon. Never mangyayari yung reaction na yan. Okay? So, yun yung idea. Kumbaga, marerelate nyo to sa marerelate nyo to sa universe natin. No, bakit? Kasi from singularity, nag-expand yung universe into Big Bang, no? And then nabuo tayo. Imagine nyo, yung stars mabubuo. Ibig sabihin from disordered particles to ordered particles. Okay? Kasi gas cloud yun eh. Disordered yun eh. Pero pinagsama-sama yun para maging star. Ibig sabihin, negative yung entropy nun. Pero nangyayari yon. Bakit? Kasi kung titignan mo naman yung delta S ng surroundings, positive yon. Nag-e-expand yung universe lalo eh. Okay? As that happens, yung universe nag-e-expand din lalo. Ibig sabihin, pag pinag-add mo yung dalawang entropy na yon, positive pa rin yun overall. Okay? So, ganun din. Kunwari, sa libro, yung makalat na libro kanina, sabi natin, negative yung entropy nun kapag yung libro binalik mo sa shelves. Sa point of view lang yon ng libro. Pero ikaw na nag-aayos ng libro, positive yung delta S mo. Bakit? Kasi ikaw yung maglalakad-lakad eh. Ikaw yung galaw ng galaw. As a result, mataas yung microstates mo. Okay? So, galaw ka kasi ng galaw pag inaayos mo yung libro. Negative yung delta S sa libro, positive sa'yo. Pag pinag-add mo yon, mas pagod ka kaysa sa libro. Kaya positive yung delta S overall. Okay? Kasi hindi bro, dadalhin mo lang doon, tapos ikaw napagod ka pa. Ibig sabihin, mas malakas yung entropy mo kaysa sa libro. Kaya positive pa rin yung delta S universe. Okay? So ano yung pinaka-notion dito? Kailangan natin i-absorb dito is that yung delta S universe, ang basis for yung delta S universe ang basis for spontaneity. Okay? So hindi yung sa system, hindi yung sa surroundings, kundi yung sa universe. Okay? So yung universe ang basihan ng entropy natin. Yun yung sinasabi ng second law of thermodynamics. Okay. So ito yung problem dito. So ibig sabihin kung gusto mo malaman kung spontaneous yung process, kailangan alam mo yung value ng sa system at ng sa surroundings. Paano ko magagawa yun? Madali lang. Okay. So madali lang kunin yung delta S ng system pati ng surroundings. Mabigyan ko kayo example. Punta tayo sa system. So suppose you have a chemical equation looking like this. The standard entropy change of the reaction is given as this. Similar to sa enthalpy. 'Di ba sa enthalpy, mole product minus mole reactant. Mole product, enthalpy product, minus mole reactant, enthalpy reactant. Ganon din gagawin natin dito. Okay? So basically, hindi na tayo baguhan dito kasi ginagawa natin to sa enthalpy. So ito yung way to get the entropy changes for the system. So that is the mole of the products times their entropy minus the mole of the reactant times their corresponding entropies. At saan mo makikita yung entropy? Nasa binigay kong table. Okay? Kaya ito, kailangan nyo i-download tong thermodynamic data. Kasi andito sa table, yung mga entropy na gagamitin natin. Ayan, no? So, yan. So, pag-add mo na lang yan. Add, subtract. Yan. Kuha mo na yung delta S ng reaction. Let's try to look at these two problems. Calculate the standard entropy changes of the following reaction at 25 degrees Celsius. Ayan, so we have calcium carbonate decomposing into calcium oxide and carbon dioxide gas. Ano ang entropy change? Positive o negative? So by just looking at the equation, we can say na ito ay positive ang entropy. Bakit? Kasi mas marami yung product mo kaysa sa reactant. Ibig sabihin, pag mas marami kang particles, mas disordered, no? Mas maraming particles sa product kaysa sa reactant, ibig sabihin, the entropy here should be positive. Pero ano yung value niya? Di solve natin. Alam natin positive ha, pero solve pa rin natin para sure. So gagawin mo, kunin mo yung mga standard entropy ng ito, pati ito. Solve mo yung S0 nila. Saan makikita yung S0? Nasa table. Okay? So tingin tayo sa S0 dito sa table dito. Yan. So we have calcium, carbon dioxide muna. So ito. So this is carbon dioxide. Yung nasa last column nito ay yung S0 niya. The entropy change, the standard entropy. Ito. So 213.6 joule per mole Kelvin. Yan yung unit ng entropy. Joule per mole Kelvin. So yan, CO2 na gas. Nasa pinaka-right side yung kanyang S0. The entropy, the standard entropy. Ngayon, mapunta naman tayo sa calcium oxide. Calcium carbonate. Ito, calcium oxide. So, dito sa table, may calcium oxide tayo. Ito. Hanapin mo yung S0 niyan. Ito. 39.8. And then we have calcium carbonate. Ito, calcium carbonate. Ang S0 niyan ay nasa dulo. Okay, so ganun. Tingin ka lang dito sa table, makukuha mo yung S0 values niya. Okay? Tapos ano gagawin mo? Apply this equation dito sa problem na to to get the delta S reaction or the delta S system. Okay? So delta S na system equals mole ng product. So 1 mole na calcium oxide times 39.8 na entropy ng calcium oxide. Mole ng carbon dioxide, i-add mo yon times the entropy of carbon dioxide minus yung sa reactant. So you have 1 mole of calcium carbonate times its entropy. And so basically, i-add mo na lang. Makuha mo na yung entropy ng system or the entropy of the reaction. Sa pag-add-add lang natin sila. Sabi natin kanina, ang hula natin positive to kasi mas marami yung particles sa product kaysa sa reactant. Ano? So, tignan natin kung tama yung hula natin na positive yan. 39.8 to 13.6 minus 92.9. Yun. So, tama. We got positive 160.5 joule per Kelvin na entropy. Nag-cancel yung mole ha. Ayan, nagka-cancel sila. Okay? So yan, that is the value of the entropy. Positive 160.5 joule per Kelvin. So again, to solve for this, hanapin mo lang yung S0 nila, yung standard entropy sa table natin. Tapos, yung products, isubtract mo sa reactant. Mole product, S0 product, minus mole reactant, S0 reactant. Okay? So, parang yung ginawa lang din natin sa enthalpy. But instead of using delta H, we use the delta S. Okay? So, ayan. So, another example would be this one. We have nitrogen gas plus hydrogen gas producing ammonia. By just looking at the chemical equation, ano kaya sign ng delta S natin? Positive o negative? Just look at the equation. Positive kaya yan o negative? Dali, any guess? Go lang. Pag may hindi na gets, you can ask ha. Tanong nyo para masundan lalo.
Positive, sir.
Okay, so positive daw. How about the others? Yung iba. Ano kaya sa tingin nyo yung magiging sign na to? Positive o negative?
Negative po.
Negative naman. May isang positive, may isang negative. Bakit kaya? Bakit kaya?
Sir, hula lang.
Hula lang. Si JC. Bakit kaya? Ba't mo nasabi na negative naman?
Naging less disordered na po sa isa.
Paano siya naging less disordered? In terms of? Malapit na. Ayun, tama na negative yan. Malapit na yung ating explanation. Ay, tama naman. Tama, negative dapat to. Kasi naging less disordered. Paano mo nalaman yon? Paano natin nalaman? Look at the equation. Sa reactant, ilan yung particles mo? Isa neto, tatlo nun. 4 yung particles mo. Pagdating sa product side, ilan na lang yung particles mo? 2 moles ng ammonia. So, 2 na lang. So, from 4, naging 2. Ibig sabihin nun, umonte yung microstates nila. Yun yung idea. Umuonte yung particles pagdating sa product, ibig sabihin, nagsasama-sama sila. Nagko-combine yung mga atoms natin. Nagko-combine yung mga molecules natin. Okay, so ibig sabihin, by just looking at the coefficients ng equation, you can tell whether positive or negative yung delta S niya. Ito, 4 yung moles dito. Pagdating doon, 2 na lang. Ibig sabihin, umonti particles. Ibig sabihin, naging less disordered siya. Naging ordered siya. So, negative yung delta S natin dito. But to further prove that, we have to solve for the delta S. Kailangan yung masolve natin ay negative para mapatunayan natin na tama yung ating hula. Okay? So, let us solve for the S naught. Okay, so solve natin yung S naught, ha? Patunayan natin na tama yung hula natin. Okay, again, yung S naught, makikita mo dito sa table. Allow me to look for them. H2 muna. Naantok ako sa sobrang init. Grabe. Paka-init. Ito, H2. So, ito yung kanyang entropy. 131 joule per mole Kelvin. So, yun yung sa H2. N2. Ito, N2. Ayun, N2. 191.5 joule per mole Kelvin. And yung ammonia, NH3. Ayun, sakto. Ito, NH3. Tingin ka sa kanan, andun yung entropy. 103. Ay, sorry, 193. Naantok ako eh. Ayan, 193 joule per mole Kelvin. Okay? So, yun yung ating mga standard entropy values. Again, they can be determined using this thermodynamic table. Okay? So, paki-download na lang. So, to solve for delta S of the system or the delta S reaction, mole product minus mole reactant. So, sa product, we have 2 moles of ammonia. So, that's 2 moles times 193 J mol K. Minus, sa reactant naman, you have 1 mole of nitrogen gas times S naught, 191.5 J mol K. Minus again yung sa hydrogen gas, 3 moles times H2. Okay. So, pag subtract natin yung mga yan, pakipindot na lang sa calcu. 2 times 193, 191, 3 times 131. Okay. And so, the delta S is negative 198.5 joule per Kelvin. Take note that the moles will cancel out. Okay? So, yan yung ating entropy change. Negative. Okay? Negative. Okay. So, ibig sabihin, tama yung hula natin kanina. Okay? Tama hula natin kanina that, yung kapag umuunti yung particles mo, negative yung entropy mo. Pag dumadami particles mo, positive yung entropy mo. Okay? So again, madali lang to. Look at the S naught sa table na binigay ko sa canvas. Tapos, ano lang, use mo yung equation na ginamit natin sa entropy. I mean sa enthalpy. Okay? So products minus reactants lang din. Same lang. Okay? So, ibig sabihin, kayang-kaya i-solve ito. So, dahil doon, bibigay ako ng maraming activities para sa prob set. However, sabi ko nga sa inyo, ang ating prob set ay, ang pasahan ay end ng semester pa. So, marami kayong time, pero I hope na wag nyo naman itambak. Okay? Wag nyo na itambak yung inyong mga prob set. Para naman, maka-abante na kayo sa buhay. Kasi baka kapag hindi nyo sinagutan to agad, makalimutan nyo na yung topic, no? So this serves as your review na rin for the finals. Kasi take note, yung final exam, ang coverage nun ay lahat ng topics na diniscuss ko. Lahat. Kaya kailangan mag-review rin kayo, no? Since wala ng quizzes, prob set na lang, edi mas maganda. Kasi nga, groupings yun. Okay? So yan, ibig sabihin, hindi na kayo mape-pressure, ha? Ayan, end ng semester pa naman eh. So I want you to get the delta S reaction of the following reactions here. By just observing the equations, dapat magka-idea tayo kung positive o negative yung delta S. Just look at the equation, kailangan malaman mo kung positive o negative yung delta S. Ito, letter F. Positive o negative yung delta S? Just look at the equation. Positive o negative ang delta S? Letter F.
Positive po.
Positive. Kasi ang daming particles. Ayan. Ang dami no? Sa reactant, dalawa yan. Pagdating sa product, 3 na. Ibig sabihin nun, positive talaga yung entropy, no? So, kailangan ang masolve mo dito na delta S ay positive. Pag hindi positive yung nasolve mo, baka may mali. Okay? About letter E. Positive o negative ang delta S? Letter E. Positive o negative? Ito ay
Negative po. Negative po.
negative. Ayun, tama. Ayun, hopefully, nasusundan na ha. Kailangan tignan nyo lang yung equation, may idea na kayo. Bakit siya naging negative, no? So, kailangan makuha mo dito negative. Bakit? 3 moles yan. Pagdating sa product, 2 moles. Ibig sabihin, umunti sila. Umunti yung particles mo. So, negative yun. Okay? Ganun yung idea. Letter D. Positive, negative.
Negative.
Negative. Bakit siya negative? Kasi 3 dito, 2 nito, 1 nun. So, 3. Pagdating dito sa kanan, 2 na lang. So, from 3 particles down to 2 particles. So, yung delta S mo dito should be negative. And for letter C, ano kaya sa letter C? Is it positive, negative, o hindi ko sure, sir? Sagot ay? Hindi natin sure. Hindi natin sure yung sagot dapat dito. Bakit? Kasi, tignan mo, 2 sa reactant, 1 nito, 1 nun. Pagdating sa product, 2 din. So, paano mo malalaman? Di solve mo. So, solve mo yung delta S. Di ko sure yan. Hindi natin sure by just looking at the equation. So, ibig sabihin, magsosolve ka pa ng delta S. Okay? Solve mo ba yan? So, ganun lang ha. Hopefully, nasusundan naman. Pag hindi, sabihin nyo lang sa akin ha. Basta, just looking at the equation, kapag mas maraming particles sa products, positive ang delta S. Pag mas maraming particles sa reactant, negative ang delta S. Okay? So, ayan. So, ayan. Following observations, pag we produce gas particles, positive ang delta S. Pag mas maraming total particles sa pag umuunti yung gas particles sa product side, negative yung delta S. And if walang change sa moles ng particles, pwedeng positive, pwedeng negative, depending sa masosolve mo. Okay? Ito, may question. Sir, in letter B po ba, paano po naging minus? Pardon me. Ito. Paano siya naging minus? Di ba ito yung product? Ito. So, positive yon. Pag reactant na yan, negative na yon. Pag product, positive. Pag reactant, negative. Di ba negative reactant tong N2? Kaya negative sign doon. H2, reactant din. Kaya negative din doon. Ayun. So, negative for the reactants, positive for the products. Ayun. Nasundan mo ba? Si Marvin. Afternoon, sir. Nag-busy ako. Okay lang. Medyo mahina talaga yung mga net natin recently. Kung nga nag-ML ako, banas na banas ako eh. Lag eh. Alam mo yung bilis-bilis ng internet pag nanonood ka YouTube, pero pagdating sa ML, bagsak. Converge pa. Ayan. So medyo mahina talaga yung internet natin recently kasi ayun. I don't know. Ayan, since meron na kayong idea how to determine whether a reaction has a positive delta S or negative delta S, try natin to. Predict whether the entropy change is positive or negative. Letter A. Positive, negative. Bakit? Sige. 1A. This is positive, negative, or di natin sure?
For sure. Need pang i-compute.
Ano?
Hindi po sure, sir. Need
Hindi
pang
sure? Tingin ulit tayo. 2 moles na to, plus 1. So, ibig sabihin, 3 dito. So, doon 2. Titignan mo yung moles ng particles mo. So, yan. So, dito, 2 plus 1, 3. Then sa product side, 2 na lang. Okay? Ibig sabihin, mas marami sa reactant kaysa sa product. So, negative to. Okay? So, yan. So, to confirm, isa-solve mo yun na negative nga siya. How about this one, letter B? Ayan. Is it positive or negative?
Positive po.
Ayun. Positive na to. Bakit siya naging positive? Kasi from isang particle, naging 2 siya. So, positive yung entropy doon. Kasi dumadami siya. Okay? So, how about this one? Letter C. Positive, negative, di natin sure. Letter C. Yung iba naman. Letter C, ang sagot ay hindi natin sure. Hindi natin sure yan. Bakit? 2 dito sa reactant, 2 sa product. So, you can't really tell. So, kailangan mo i-compute para malaman mo. O, letter D. Ito, letter D. Is that positive, negative?
Positive po.
Positive, no? Bakit siya naging positive? Kasi Positive siya kasi naging dalawa siya. No? From isa, naging dalawa. So, positive yan. O, letter E. Ito, tutuloy ko na. No? So, for letter E, this is negative. Kasi tatlo yung reactants, dalawa lang yung product. So, negative yung delta S dyan. And then for letter F, we can tell. Hindi rin natin masasabi. Kasi dalawa yung reactant mo, dalawa din yung products mo. So, hindi mo sure. Okay, so, solve mo pa yan. Okay. So, yan. Gusto ko i-solve nyo. Solve nyo rin yung delta S not neto. Okay, so kasama to sa problem set, ha? Ayun, medyo marami kayong sasagutan sa prob set. Pero again, practice na yan, no? End pa naman ng semester ang pasahan. Pero gaya nga ng sinasabi ko, wag nyo paabutin sa end ng sem para makapag-review kayo agad, no? The earlier you answer this, the earlier din yung review nyo. Okay? So, yan. Ayan, so ito. Mahina siguro talaga net, no? Anyway. So ito yung prob set natin. Dinagdag ko na, ha, other than this, no? So please work on them. Lahat ng S naught values nila ay nasa thermodynamic table na pinakita ko kanina. Okay? So medyo malapit na tayo sa katotohanan. Kasi sabi ko sa inyo, para malaman nyo yung spontaneity ng reaction, ang kailangan mo makuha, yung delta S universe. Yung sa system, alam na natin yan. Okay na tayo dyan. We now know how to solve for the delta S reaction. But how about the surroundings? Paano sa surroundings? Yun yung aalamin natin ngayon. Yung sa reaction, okay na. Sa surroundings, paano? Ganito. So, paano ba nata-transfer yung energy from system to the surroundings, no? Dalawa 'yon. Pwede work, pwedeng heat, 'di ba? From system to surroundings, dalawa 'yan, 'di ba? Work then heat. But the common one is the heat, okay? So, heat yung gagamitin natin kasi yun yung common talaga, no? So, ibig sabihin nun, when our system undergoes entropy changes, there is also a heat transfer between the system and the surroundings, no? Okay? So, kapag yung ating system naglabas ng heat, ibig sabihin yung sa surroundings, doon mapupunta yung heat, no? Ano mangyayari kapag naglabas ng heat yung ating system papunta sa surroundings? Iinit yung surroundings, no? So, since umiinit sa labas, tumataas yung entropy ng labas ng surroundings, no? Consequently, kunwari naman yung reaction natin, nag-absorb siya ng energy. Pag nag-absorb ng energy, sabihin yung surroundings natin lalamig. Therefore, bababa entropy niya. So, ano yung logic dito? The logic here is this, no? You can determine the changes in the entropy ng surroundings by determining the heat given off or taken in by the system. Okay? So that's why we write the equation, ito, ds surroundings proportional sa negative dq system. Bakit negative sign? Kasi sabi ko nga, pag yung system naglabas ng heat sa surroundings, negative yun, di ba? Yung sign nun. But as a result, positive yung sign for the surroundings. So ds surroundings, negative dq system. Okay? So take note of that na. So negative for the system kasi siya yung maglalabas ng energy. Positive for the surroundings kasi siya yung tatanggap. Okay? So ds surrounding proportional to negative dq system. So the negative sign is the sign convention that tells us the direction of the flow. Or at constant pressure system, pag constant pressure, delta S surroundings lang yan. The heat at constant pressure is the enthalpy. So, delta H system yan. Di ba alam na natin paano mag-solve ng enthalpy? No? Alam na natin yan eh. Enthalpy long reaction sa calorimetry. So, basically, alam mo na how to get this. So, kung alam mo na how to get this, then you can get the entropy ng surroundings. What else? No? Apparently, the amount of entropy change for the surroundings is inversely proportional with the temperature of the surroundings. Ano meaning nun? Tagalogin natin. Yung changes daw sa temperature ng surroundings ay inversely proportional sa temperature ng surrounding. Ibig sabihin, kung mainit na sa surroundings, onti na lang yung temperature, onti na lang yung entropy changes. Kasi onti na lang yung heat na kailangan eh. Okay? Pero kapag malamig yung surroundings, mas malaki ang entropy change. Bigyan ko kayo ng logic, no? Medyo hindi siya related pero sana makita natin yung point natin dito. Kunwari, sa Pilipinas, okay, ano temperature ngayon? 37 degrees. Taasan mo yung temperature to 38 degrees. Madadama mo ba masyado yon? Hindi. Bakit? Kasi nasa impyerno na tayo. Mainit na talaga sa Pilipinas, di ba? Ibig sabihin, dagdagan mo man yung temperature, parang wala na. Wala na siya masyadong effect. Kasi ang init na eh. Okay? Ibig sabihin, yung entropy change sa paligid kapag mainit na, hindi mo na masyado madadama. Okay? Kaya inverse yung relationship. Compare mo yan sa ibang bansa. 'Di ba sa Britain, no? May balita doon sa Britain, 23 degrees Celsius lang. Heat wave na daw 'yon. Sasabihin ng mga Pilipino, ay napakahina naman. Actually hindi, no? Kasi ganito yung sistema sa ibang bansa. Parang ganito lang din 'yon. Sanay sila na malamig yung temperature. Ibig sabihin, pag tumaas yung yung heat sa paligid, no? Mas dama nila yon kaysa sa atin. Kasi nga, sanay sila sa malamig, no? So, ibig sabihin, onting increase sa temperature, mas dama nila. Kaysa naman sa atin. Sa atin kasi, kahit pakuluan mo na yung buong Pilipinas, wala lang. Sanay na tayo na mainit, di ba? Kasi, mataas na yung temperature to begin with, no? So, ibig sabihin that entropy change is small. However, if you are at colder regions, no, pag malamig sa paligid mo, pag nag-release ng heat yung isang object, mas dama mo. Okay? Mas dama mo yung init kapag malamig sa surroundings. So, yun yung reason. No? Inverse ang relationship ng temperature and the entropy. Okay? The higher the temperature is, the lower yung natin. The lower yung mapupunta sa surroundings. No? Again, sa surroundings yung point of view, ha? Okay? Hindi sa system. Okay. Surroundings na tayo. So, yun yung idea dito. So, ayan. We have this equation. Gawin mong constant pressure. Okay, so, that will turn into delta S equals negative delta H system over T. Okay. Delta H system over T. So, basically, if you have a chemical equation, you are given the delta H of the reaction. Ito, i-divide mo na lang sa temperature para makuha mo yung delta S surroundings. Okay? So, for example, ito yung equation. Nakuha na natin yung delta S system as this. 198.5 yan. Ginawa ko ng 199. And yung delta S surroundings can be calculated using this equation. So, ito, i-plug in mo yan doon. Yung temperature, plug in mo dyan. Ayan. Yung kilojoules, gawin mong joules. Ayan. So, you will get this value for the surroundings. Then, to know if the reaction is spontaneous or not, kailangan makuha mo yung delta S universe. So, add mo yun sa system, pati yun sa surroundings. Yung system, na-solve natin yung kanina. Yung surroundings, paano yan? This divided by the temperature lang. Then, negative sign. Okay? So, this, pasok mo lang doon. Temperature, pasok mo doon. You will get your delta S surroundings. So, kapag pinag-add mo ito, pati ito, you will get a positive delta S universe value. So, ibig sabihin, although this reaction has a negative delta S system, this will still happen. Bakit mangyayari pa rin to? Because of the delta S universe. Okay? So, because of the delta S universe, this will still happen. So, ano yung takeaway natin dito? Ang hirap. Mahirap, literally. Bakit? Kasi, para malaman mo pala kung spontaneous yung isang reaction, kailangan alamin mo Yung sa system, pati yung sa surroundings. Hindi ba parang nakakapagod yun? Oo, nakakapagod yun. Okay? Kaya gumawa na naman sila ng another form of energy called the Gibbs free energy. Okay? Gibbs free energy, which is i-discuss natin next meeting. Okay? So yan. So this is a temporary way of determining the spontaneity of reaction using the delta S universe. Okay? So delta S system can be calculated using the equation we used earlier. The delta S surrounding can be calculated using this equation, negative delta H over T. So this divided by the temp lang, negative sign. You will get the delta S surroundings. Pag-add mo yon, you get the delta S universe. If the delta S universe is positive, then spontaneous yan. Okay? Pero gaya nga ng sinabi ko, mahirap to. Kasi to just know kung yan ay kung yan ay spontaneous ay ang dami mong isosolve, no? Yan ang kapagod yun. Kaya next week may i-discuss tayong shortcut. Okay? Yun yung Gibbs free energy. Okay, so we're done with entropy na. Tapos na tayo medyo. Punta na tayo sa mga last part ng ating discussion. Third law of thermodynamics. Anong ganap lang nito? So kapag meron kang crystalline solid, pag ang temperature niyan ay absolute 0 or 0 Kelvin, ang mangyayari is that it will only have one microstate. Kasi kapag ang concept ng absolute 0, yung particle di gumagalaw. So ibig sabihin nun, yung microstate niya ay 1 lang. So yan yung idea dito sa third law. Kapag absolute 0 yung temperature, yung particle hindi gagalaw. Therefore, it will have one microstate only. Okay? So kung ipa-plug in mo yan sa ating Boltzmann equation kanina, you will get S equals 0. So ano yung purpose lang nito? The purpose is that we can establish the reference for the standard entropy changes. Okay? So may reference na tayo. Kasi sa enthalpy, di ba may delta HF formation tayo equal to 0. Yun yung reference natin. For example, yung oxygen gas, 0 yung enthalpy of formation nun. Carbon graphite, 0 yung enthalpy of formation nun. Yun yung mga reference natin. Pero sa entropy, ang reference natin ay yung third law of thermodynamics. No? Na yung solid, pag naging absolute 0 yan, 0 yung entropy niya. Okay? Because it will only possess one microstate. And using this concept, dun nila nakuha yung mga standard enthalpy values. Okay? I mean, standard entropy values. Okay? So yun lang. Nothing significant na yung gagawin natin dyan. Okay? So punta na tayo sa last part, no? Impacts on engineering. Ito na yung last topic natin for today. So, alam nyo ba na itong discovery ng entropy, no? Ito ay naging vital sa Industrial Revolution noong 1800s sa Europe. Okay? So ano ba nangyayari noong Industrial Revolution? We started relying on machineries, no? Gumagawa na tayo ng mga tren to transport more people kaysa dati sa kabayo lang. May tren na tayo ngayon that time. Okay. So isa sa mga driving force ng Industrial Revolution ay yung entropy. Okay? Yung science. Okay. Ganun katindi yung yung belief ng tao sa mga scientists dati. Kaya malaki respeto nila. Kasi nga, sila yung dahilan bakit nagkaroon ng Industrial Revolution. Compare mo yan ngayon. Pag ikaw scientist, hindi ka, aawayin ka pa ng mga tao. No? Aawayin ka kasi against daw sa religion nila yung science. No? Aawayin ka nila kasi against sa political will nila. No? Against sa kanilang belief, no? 'Di ba ganun sa Pilipinas ngayon, no? Pag ikaw yung doktor, parang kasalanan mo pa na sabihan mo yung tao na ganito ganyan, no? Pero before, nung unang panahon talaga, 18th century, masyadong grateful yung mga tao sa scientist, no? Kasi without them, hindi magi-improve ang civilization natin. Sana ganun pa rin ngayon para mag-improve lalo yung civilization natin. Pero anyway, let's go back to the application sa engineering, okay, ng entropy. So since yun nga, Industrial Revolution, we started making machineries. Nagkaroon na tayo ng heat engine. Ito yung ginagamit sa tren. Okay? And even sa sasakyan ngayon. Okay? So ano yung idea ng heat engine? 'Di ba nanonood kayo ng yung tren, si Thomas, 'di ba? Yung tren na yon. Ano yung itsura ng Ano yung itsura ng locomotive train na yon? Okay? Heat engine train. Pakita ko sa inyo, steam engine. Ayan. Ito si Thomas and Friends. Okay. Ito ay heat engine. Bakit? Paano? Paano? Okay. Dito sa harap, may tubig dyan. Okay. Tapos 'di ba may mga sinusunog na kahoy dun sa likod, kaya may usok yon. May sinusunog na kahoy dyan. So that, yung ating yung ating water ay mag-evaporate. When the water evaporate, it converts into gas. Kapag gas yan, may piston dyan sa ilalim. And yung piston na yon, it will, expansion contraction yan. Expand contract yan. Okay. So parang ito nakikita nyo sa clip natin. Pag nag-expand contract yan, ano mangyayari? Yung wheel, iikot. So gagana yung tren. So ito ay isang heat engine. Okay. So it uses the concept of thermochemistry and entropy. Okay. Imagine nyo, without science, wala tayong tren, no? Okay. Ay, ano pala kayo? DRET kayo, no? Oo nga pala. So medyo important to sa inyo, no? So yan, ito yung heat engines, no? So yan, susunugin mo yung kahoy, mag-evaporate yung tubig. As a result, yung piston, mag-up, down yan. So gagalaw yung tren and then lalabas yung usok, di ba? Magchuchu siya diyan, no? Okay. So ito yung isa sa mga tulong ng science sa Industrial Revolution. Okay? So ito yung heat engines na yan that was conceptualized by a French engineer, Sadi Carnot. It should be Sadi Carnot. Maririnig nyo yan pag pag nag-majors na kayo. Okay? Kasi railway kayo. So si Sadi Carnot, siya yung isa sa mga pioneer in creating heat engines. Okay? So ginamit niya yung concept ng entropy. Okay? So according to him, sabi nga natin kanina, entropy is a state function. Ibig sabihin nun, it doesn't depend kung saan ka nag-start or saan ka natapos. Basta i-subtract mo yung difference nun, yun yung value ng delta S mo. For heat engines kasi, the process is cyclic. Okay? Ikot-ikot lang. 'Di ba yung ating heat engine, yung piston nun, back and forth yan eh. So ibig sabihin nun, cyclic yun. Back and forth kasi yung ating piston. And mathematically speaking, if we have a cyclic process, the cyclic integral is equal to 0 if that is a state function. Bakit 0? Kasi kung ano yung start mo, yun din yung end mo for a cyclic process. So kung saan ka nag-start, doon ka rin mag-end. So 0 yung delta S mo. Okay? So ibig sabihin, during the process ng pag-andar ng tren, expansion and contraction ng piston, ang overall delta S nun ay 0. Okay? So yan. So ano daw nangyayari sa heat engines, no? So Sadi Carnot further explained that these are the following processes that happens inside a heat engine. Okay? So 4 daw na steps yung nangyayari sa heat engine. Una is the expansion, wherein the gas will push the piston forward. Then after nun, the second part of the process will be the contraction. Yung babalik yung piston. And then that will go on and on until makapunta ka sa gusto mong destination. Okay? So to be more specific, yung expansion and contraction ng ating ng ating piston ay ito yung processes na ina-undergo niya. 4 yan. Okay? So the first one is the reversible isothermal expansion. Okay? At high temperature. Siyempre, mainit yung mainit yung gas natin eh. Mainit yung water vapor. Okay, so ibig sabihin we have a high temperature. So this is the first process daw which happens at high temperature. Okay? So ito yung reversible isothermal expansion. The entropy change for this one, okay, is equal to dq over t. Ito yung ginamit natin kanina. Okay? So since this is at hot temperature, ibig sabihin may heat tayo at hot temperature over temperature ng hot reservoir. Okay? So whatever that integral is, ito yung value niya, QH over TH. The heat at the hot reservoir divided by the temperature of the hot reservoir. Okay. So ito yung may apoy. Okay? Dito yung kumukulo yung tubig. Then ano yung susunod na step down? Sabi ni Sadi Carnot, after the reversible isothermal expansion, we will have this process. Itong process na to. Second process, that is the reversible adiabatic expansion. Next is the reversible adiabatic expansion. Okay, so yun yung kwento niya. So ano yung entropy change? So second step natin. Sabi natin kapag adiabatic, walang heat transfer. So ibig sabihin itong integral na to ay 0 yan. Kasi wala tayong change sa heat. Okay? So wala tayong change sa heat, no? Okay, so by the way, this is still PV curve, no? So dito sa second step, we don't have entropy change kasi nga ito ay reversible adiabatic expansion, and when we have adiabatic processes, dq is 0, therefore entropy is 0 as well. After nyan, nag-expand na yung ating piston. Ano susunod? Magko-contract na yung piston. Babalik na siya sa original position niya. So, expansion, then later on, contraction. Tapos, ulit-ulit yan. Okay? The third step for a heat engine daw is this one naman. So, pag magko-condense na yan, yung gases sa loob, ibig sabihin malamig na. So, kanina nasa hot region tayo. Ngayon, nasa cold region na tayo. We are now at the cold reservoir. Ito, hot reservoir. Hot. Ito, cold reservoir na tayo. Okay. So, dito na tayo sa step 3. Nangyari daw sa step 3 ay reversible isothermal compression. Okay. So, for step 3, alamin daw natin yung entropy niyan. So, dq over t yan. So, since we are at the cold region, ibig sabihin, kung ano man yung QC divided by the temperature cold, yun yung inyong entropy. Okay? So, at the cold region, ito daw yung entropy natin. QC over TC. Okay? And then, lastly, ano mangyayari? Magkakaroon ulit tayo ng last step, which is the reversible adiabatic compression. So, yun yung last step. So, since adiabatic uli yan, the entropy change is 0 for the last step. Okay? So, ito yung mga nangyayari daw sa heat engine. No? Kapag gumaganong-ganon yung piston, nagba-back and forth siya. Okay? So, mag-expand, then mag-contract, no? So during the expansion, may isothermal and adiabatic expansion. And during the contraction, merong isothermal and adiabatic compression. Okay? And that will go back and forth, no? Okay. So since that is a cycle, the total entropy change is zero. Okay? So ibig sabihin, pag pinag-add natin tong lahat ng entropy na to, so QH over TH plus 0 plus QC over TC plus 0, lahat daw yan ay equal sa 0. Okay? So QH over TH is equal to, plus QC over TC is equal to 0. Ito yung ginamit ni Sadi Carnot, no? Para saan? Later. So basta yan yung sabi ni Sadi Carnot, no? That for a heat engine, there are 4 thermodynamic processes that happens, no? Yan, so the expansion, compression. Okay? And then if you get their corresponding entropy changes, ito yon. Take note that for adiabatic processes, 0 yung entropy changes kasi dq over t yun eh. If walang dq, kapag 0 yun, edi 0 yun, delta S. And sabi nga natin, for a cyclic process, pag pinag-add mo yan lahat, equal yan lahat sa 0. So we will get this equation, QH, TH, QC, TC. Okay? So yan. So yan. Or in other terms, that can be written as QH, QC equals to TH, TC. Paano nangyari yan? Diba QH, TH plus QC, TC yan, diba? Lipat mo lang sa other side. You just transpose it to the other side. Magkaka-negative sign doon. Cross multiply, so you will have this. Okay, so you will have this equation. Cross multiplication lang. So for a Carnot engine, QC, QH over QC is equals to negative TH over TC. So ngayon, saan nila ginamit yan? No? Sa efficiency. In designing a steam engine, no? Or in designing a heat engine, kailangan it should be efficient, no? Para hindi sayang yung energy mo. So when you say efficiency, ito yung how much yung inyong energy ay convert into useful work. Okay? So yan. So the efficiency for a heat engine is given as the eta. This is a Greek letter eta. Okay, so that's equal to work output divided by the heat absorbed from the hot source. Okay? So ibig sabihin yan, the more work yung kaya i-produce ng engine mo, the higher your efficiency will be. Okay? So the higher yung efficiency. Kasi kapag mababa lang yung work na nakukuha mo sa heat engine, as in super init niya, tapos hindi naman gumagalaw, hindi efficient yon. Okay? Papalitan mo yon kasi sayang yung energy, sayang yung resources. So the work for a heat engine is this, no? So that can be calculated as the difference of the energy from the hot reservoir and the cold reservoir. So kung ano yung difference nila, yun yung nagagamit as work. Okay? So we can express W as QH minus QC over QH. And then, divide mo yung QH. So we will get 1 minus QH, QC over QH. Yan. So we will get eta equals 1 minus QC over QH. Then substituting what we solved earlier. Okay. So kanina, QH over QC, TH over TC. Baliktarin mo yan. QC over QH is TC over TH. So yan. We can substitute the Q to T. No? So ano yung purpose neto? Ibig sabihin nun, you can now calculate for the efficiency by just determining the temperature of the hot and the cold reservoir. Okay. Yun yung ginawa ni Sadi Carnot. So para hindi ka na mahirapan mag-solve for Q, gamit ang entropy, na-convert niya yung Q into temperature. So ibig sabihin, in designing heat engines, all you have to do is to adjust the temperature capacities of your reservoir, the hot and the cold reservoir. Okay, so if it can handle higher temperatures, then the efficiency will be very high, no? Okay, that's why ito yung focus ngayon sa mechanical engineering, no? Kasi sa mech-eng, they are the ones designing engines, no? And in creating engines, you should take note of this, no? Ito. So you should take note of the Carnot efficiency or this equation. So this equation will tell us if maganda ba yung engine na ginagawa mo o hindi. So according to this equation, in order to get higher efficiency for your engine, kailangan mas mainit yung kaya niyang reservoir. Okay? And also, mas malamig yung cold reservoir. Okay? Kasi kapag malamig ito, low yan, as ito mataas yan, yung fraction na yan ay maging maliit, no? Maging decimal yan. So, pag mas maliit yan, ibig sabihin, 1 minus the maliit na number will be a high number, no? Approaching 1 siya. So, mas mataas efficiency mo pag ganun. Okay? So, ito yung trend na ginagawa sa mech-eng, no? They design materials na kaya yung high temperatures, no? Kaya gumagamit tayo ng mga alloys, no? Hindi lang iron yung gamit, no? Hinahaluan nila ng ibang metals yung ating mga casing for the engine so that it could handle higher temperatures, no? Because according to the efficiency, mas efficient ang engine kapag mas mainit yung kaya niyang i-handle na temperature. Okay? So ito yung ginagamit in designing cars and rocket engines and saan pa ba ginagamit to? Sa train dati, ngayon hindi na kasi kuryente na lang. Okay. Pero yun yung idea. Okay? So basically, ang ginawa lang talaga ni Sadi Carnot is to convert the Q to temperature. But without the knowledge of entropy, hindi mo magagawa yun eh. So, di ba? Kailangan mo pa mag-entropy para ma-convert ito into this one. Kasi ito mahirap to i-solve eh. Ito madali lang. Thermometer lang yan eh. Di ba? So, you will now get an easier way, no? Para ma-solve yung efficiency. Okay? Later, solve natin yung mga efficiency ng engines. Last part will be the refrigeration. Ano yung nangyayari sa ref naman? Okay. So mapansin nyo sa refrigerator, yung mainit na bagay, ginagawa natin malamig. Okay. So basically, negative yung entropy nun. Okay. So non-spontaneous dapat yun. Pero that happens kasi we apply work sa system. So ginagawa natin yung heat from the cold reservoir, yung nasa loob ng ref, tinutulak natin yung heat sa loob ng ref palabas sa likod ng ref, sa radiator. Okay? So, paano nagagawa yon? With the help of work from the compressor. Okay? So, yung compressor, siya yung mag-a-adjust ng temperature sa loob pati sa labas, and as a result, yung heat matatransfer palabas, no? Papunta sa likod. No? Kaya yung ating for example, nag-aircon kayo, mainit sa loob ng bahay pero sa labas super init, no? Kasi ang ginagawa lang nun is pinapump out niya yung init sa loob palabas, no? So during that process, kailangan mo ng work. Pwedeng in the form of kuryente. Okay? Kaya sinasaksak yung ref sa kuryente kasi kapag di mo sinaksak yun, wala ka neto. Okay? So basically, this is the reverse of the heat engine. Okay. So sa heat engine, baliktad yung flow from hot to cold, then may work na mapoproduce. Pag refrigerator, baliktad naman. From cold to hot, then you need work to transfer the energy from this cold region to the outside region. Okay? So yan, still using the same equation we derived earlier. So yan, so still using the same equation, QC over QH equals TC over TH, no? TH over TC pala. Okay. So we can now get the C, the coefficient of performance for refrigerators. So instead of using efficiency, we use now the coefficient of performance. So according to them, coefficient of performance is QC over work, and the work can be calculated as the difference of the hot reservoir and the cold reservoir pa rin. So doing multiple substitutions, you will get this equation. Coefficient of performance is equals to The temperature of the cold reservoir divided by temperature of the hot reservoir minus cold reservoir. So ito na ngayon yung equation na ginagamit nila in designing refrigerators. Okay. So ito yung ginagamit nila sa subject na HVAC. Okay. Ayan. Sa engines, ayan. So yan yung mga equations na ginagamit ng MECEng, which I think you will be familiar with naman in the future kasi kayo ay engineering students. No? So most likely baka madaanan nyo rin yung itong mga to ulit. Okay? So yan. So ang purpose lang ng thermodynamics dito is to convert the Q calculations into temperature. Okay? Yun lang ginawa niya. Lahat ng Q, ginawa niyang temperature. Okay? Kasi mahirap gawin yung Q eh. Yung temperature, madali lang. Lagay ka lang thermometer. May sagot ka na. Okay? So yun yung tulong niya sa pag-design ng engines, no? And ref, no? Okay? So, pasalamat kayo sa ref nyo kasi although negative ang delta S pag pinapalamig mo yung objects, it is still possible. Kaso nga lang, gagamit siya ng kuryente. Okay? So yan. So to end our session today, let's answer some of the problems para mas ma-visualize nyo how to use those equations. Number 1, calculate the Carnot efficiency of a primitive steam engine operating at 100 degrees Celsius and discharging at 60 degrees Celsius. No? Okay. So kunwari ito yung mga lumang trend. Ito yung mga PNR kunwari. Although efficient na yung PNR, no? Kunwari lang, mga 1800s PNR. Okay. Calculate daw natin yung efficiency niya. Take note that the efficiency can be calculated as eta 1 minus Tc over Th, where yan yung temperature na high and cold. By the way, the temperature should be written in Kelvin. Okay, kailangan naka-Kelvin ka. For the cold reservoir, yun yung lower temperature. I-convert mo yan to Kelvin. So that will be 333.15 Kelvin. And yung hot reservoir, yun yung 100. Convert mo yan into Kelvin. That's 373.15 Kelvin. Okay, so just temperatures lang kailangan mo. You can get the efficiency. So yan, so calculate mo na lang yan. The efficiency is 0.107 or 10.7%. Napakapangit. Napakapangit ng engine na yan. Bakit? Kasi only 10% will be used. No? Yung remaining 90% tapon sa environment yan. Okay. So ito yung mga engine na ang dami mong kailangan na energy na ilagay tapos unti lang pala yung igagalaw niya. Kasi 10% lang nagamit niya sa work. Eh. Okay. So yun. And pangit yung engine na yan. No? So, gagawin mo, kunwari, ikaw, engineer ka na gumagawa ng steam engines, no? You will make sure that the temperatures will be high for the hot reservoir. Okay? Magde-design ka ng makina na kaya mag-handle ng high temperature. So, let's try this other problem. Ganun pa rin. Although this time, 300 degrees Celsius na ang hot reservoir at ang cold ay 80 degrees Celsius. Tataas kaya yung efficiency? Dapat lang tumaas. Kasi you increase the temperature. Okay, so this will be 573.15 Kelvin, hot temperature. Cold temperature will be 353.15 Kelvin. Okay, so solve natin yan. The efficiency is now given as 384 or 38.4%. Okay. So papansin nyo, the efficiency of steam engines can be increased by adjusting the temperature of the high reservoir. Okay. So, ibig sabihin yan, mas marami kang energy na magagamit as work. Okay. Ibig sabihin, mas efficient yung paggana ng engine mo. Okay? Okay, bilang mga railway engineers in the future, siguro may subject kayo about this na kaya madadaanan nyo ulit to. No? But for now, ganyan lang siya muna. Pero mas magiging complicated pa yan pag nandun na kayo sa mismong subject nun na yan. About thermodynamics ng trains, no? Or ng mga engines. No? Alam ko may ganun pa kayong subject. No? Kaya for now, at least may idea na kayo. Okay? Ganyan lang siya. Dali lang. Okay? So for you to practice with those equation, prob set na lang tong 2. Pati itong 3 prob set na rin yan. Same equation lang gagamitin. So to calculate for the efficiency, that will be 1 minus Tc over Th. Always take note that the higher temperature is, the higher the efficiency of your heat engine. For other questions here, mapansin nyo may mga work siyang sinabi. So, anong gagamitin mo doon? Ito. So, kapag may mga work na sinabi, pati mga heat, ito rin gagamitin mo na equation. Take note na kailangan naka-absolute value. Basically, substitution lang yan. So, I want you to practice this. No? And ako na rin, ito sabi dito, how much heat is discharged into the cold sink in a reversible process for each 1,000 kilojoule, 1 kilojoule supplied to the hot source? O inahanap yung QC, given yung QH, yung itong efficiency mo, susolve mo sa first sentence. Okay? Ayun, substitution lang yan, okay? So I want you to work on that na lang. And for the last one, sa refrigerator, wag natin kalimutan yung ref. Yung ref natin, ang efficiency niya ay in terms of coefficient of performance. No? So the COP for ref ay ito. So that's TC, TH minus TC, yung equation sa taas. Okay. So all you have to do is to plug in the cold temperature and the hot temperature in Kelvin. So 20 degrees Celsius is 293 Kelvin. And the hot temperature is 35, which is ilang Kelvin yan? 308.15 Kelvin. Okay. So yan. So basically, plug in ka lang ng temperature dito. Then you will get their coefficient of performance. So the coefficient of performance for this refrigerator is 19.54. Actually, yung MECeng, ang ginagawa nila, itong coefficient of performance, pwede mo yung ma-convert into energy efficiency. Yung energy efficiency, yun yung nakapaskil sa ref natin. Di ba, pag bibili kayo ng ref, may papel na nakadikit sa harap nun. Nakalagay doon, energy efficiency, 388. No? Yung kasi yung nasa ref namin, 388 daw yung efficiency niya. Paano na-solve yun? Ito lang. Pwede mo to i-convert to that na. But I don't know the equation. Okay, pero yan. So ito yung ginagamit nila in designing refrigerators. No? The higher the coefficient of performance, ibig sabihin, the better your refrigerator is. No? Mas maganda siyang ref. No? Okay? So ayun lang. So yan, that's all for our session today. Next meeting, we will discuss the Gibbs free energy. Again, ang issue with the delta S is universe yung kailangan mo hanapin eh. So Gibbs free energy ang sasagot ng problem na yon to make things much more easier. Okay? Takeaways na lang tayo for this entire session. Una is that entropy can tell us the spontaneity of reaction. Okay, so the more disordered your universe is, the more entropic it is. No? Ibig sabihin, mas favored yan. Okay? So ito yung actually is isa sa mga reason why they tell na we may someday die by heat death, no? By entropy death. No? So, mangyari kasi sa universe daw is mag-expand siya na mag-expand to increase the entropy. However, ang result nun ay, masyadong malayo na yung mga particles for them to interact. So, basically, the universe will be a dead soup of particles. Okay. So, yun yung isa sa mga reason kung ba't mamamatay tayong lahat sa universe. The entropy. Okay? So, always forward lang, never backward. What else? Ayan, you can determine the changes in entropy by just observing their microstates. No? Kapag yung particles natin mas lumalaki, o mas dumadami, ayun, mas positive yung entropy nun. Pero kapag umuunti sila, ibig sabihin nun ay negative ang entropy. So according to the second law of thermodynamics, no, to tell if a reaction is spontaneous or if a process is spontaneous, then you have to look for the delta S universe. No? The delta S universe is the sum of the delta S system and the delta S surroundings. It should be positive para maging spontaneous yan. Okay? So how to solve for the delta S system? Madali lang yan. We use this equation. Plug in lang yan. So you get your delta S reaction or the delta S system. For the surroundings, mangyari, gagamitin mo yung enthalpy change. No? So you will instead use this equation, delta S surrounding equals negative delta H system over T. This is the equation used to determine the delta S surroundings. So from those two equations, you can get your delta S universe, and if that is positive, then that means the reaction is spontaneous. No? Okay. And ang application na to sa engineering is the heat engine. No? For a heat engine, that is a cyclic process. So ibig sabihin nun, zero yung overall entropy change. No? So using several equations kanina, we were able to relate the heat and the temperature of the two different reservoir for an engine. Okay. So using that, we use the efficiency equation so we can solve for the efficiency of any engines. No. Refrigeration is the opposite. No. Instead of producing work, ang refrigerator kailangan niya ng work. No. Electrical work, kailangan niya ng kuryente para gumana siya. Okay. So the efficiency for the refrigerator is given by the coefficient of performance, which have the equation TC over TH minus TC. Okay. So yan, marami pa kayong madidiscover about this once you get into your major subjects na sa railway engineering na. So gamitin niyo tong topic na to as an inspiration to further consider this program kasi alam ko naman karamihan sa inyo hindi talaga gusto itong railway engineering, no? But ayun nga, using the mathematical stuff we did earlier, no? Parang interesting ito, no? At saka malaki sweldo sa railway, no? Iilan lang kasi nagre-railway sa Pilipinas, no? Maging driver ka nga lang daw ng railway, alam niyo magkano sweldo? 50,000. Okay. Ganon. Paano kaya kung engineer ka ng railways, di ba? Ay, mas malaki sweldo nyo nun. Okay. Ayan ha. So I wish you consider this program, although hindi nyo naman to first choice, probably. Pero using using all these equations, sana mas matuwa kayo kasi interrelated yung topics natin sa main program nyo. Kaya ayun. So please pursue this program. Kasi malaki ang sweldo pag naging railway engineer ka. Unti lang kayo eh. Okay? So yun lang. By the way, ano pa pala yung possible implication nito? About efficiency. Ang possible implication ng efficiency is the idea that perpetual motion machines are fake. No? Ano yung perpetual motion machine? No? Yun yung mga machine daw na pwede ka makakuha ng energy perpetually, no? Bakit? Kasi ang assumption, if you have a perpetual engine machine, is that the efficiency is 100% or greater than that. For you to harvest energy, kailangan greater than 100% yung efficiency. But is that possible? No. So by just looking at this equation, the efficiency will always be less than 100%, no? The efficiency will always be less than 100% kasi may temperature differences na kailangan i-consider. Hindi pwedeng maging zero yan eh. Kasi obtaining absolute zero is very difficult. Obtaining very high temperature is also very difficult. So ibig sabihin, for any engines, imposible na maging 100% yan. Always less than that. No? Kaya nga ang term namin dito sa entropy is that lahat na binigay mo pero kulang pa rin yung babalik sa'yo. No? Okay? Parang ano lang yan, parang naghanap ka lang din ng jowa. No? Binigay mo na lahat, kulang pa rin. No? Isipin mo na lang, efficiency kasi ng heat engine yon. Always less than 100%. No? Hindi lahat ng ibinigay mo ibabalik sa'yo. Kasi yung iba, na-waste. No? Okay? Na-waste as heat discarded from the system. Okay? So, yun yung idea sa Carnot engines. Okay? So, ibig sabihin, pag nakakita kayo ng fake videos sa YouTube, perpetual motion machine, wala. X na yon, okay? Kasi maraming ganun sa YouTube eh. Mag-i-incognito ako. You can watch this TED-Ed video about perpetual motion machines. May TED-Ed video dito. Why don't perpetual motion machine ever work? Ang sagot dyan ay entropy. So yan. So diniscuss natin yung sagot dito. Okay? So ibig sabihin, ito man nakikita nyo sa YouTube na forever daw yung gagalaw. Joke lang yan. Joke time lang yan. Kaya mapansin mo yung mga video niyan, ilang minutes lang. Oh. Okay. Ayan, kunwari ito. 5 minutes lang. Kasi nga, joke time lang yan. Okay. Huwag kayo maniniwala sa mga kalokohan nila na yan. Okay? Kunwari, ito daw, tuloy-tuloy yan. So, pwede ka maglagay dyan ng turbine, mag-generate ng kuryente yan. Ang sagot doon, hindi. Kasi magbabago yung center of mass. Ayan. Okay, so you can watch several videos explaining why they don't work. But the answer will go back to our discussion for today, which is about entropy. Okay? So, ayan. So, mas ma-appreciate nyo yung topic natin pag nanood kayo ng other videos like this one sa TED-Ed. Okay? So, with that, so thank you for attending our session. Okay, pasensya na, ang daming equation. No? Pero mas onti yung equation kaysa sa nakaraan. No? So, yan. So, this is the lecture slide. Ito yung table. And I will post the videos once uploaded dito sa discussion. Okay? So, please enjoy your weekend muna. And I will see if makapagklase tayo sa Wednesday. Check ko muna kung makapagklase tayo sa Wednesday kasi every Wednesday kasi may ako sa Lasal eh. May klase. Baka mamaya may pa-quiz uli eh. Kaya yun. Kaya kung hindi tayo makapagklase ng Wednesday, sa Sabado na lang. Okay. So, again, hindi naman na tayo magra-rush kasi ang dami na nating vacant days. No? But we will still try to accomplish the desired topics for every week. Okay? So with that, so thank you for attending our session. Ayan. So if you have any question, don't hesitate to ask me na lang. And again, yung mga prob set, huwag kalimutan na magpasa. Ang deadline naman ay end pa ng semester. Okay. Ayan, nilagay ko dyan. Deadline is until July. Okay. So matagal-tagal pa. Okay. So yun lang. Again, wala na tayong quizzes. Ito na yun. Yung 2 quizzes na nilagay ko, yun na yun. Okay. But for the others, prob set na lang and the final exam. Okay? And so thank you for attending our session. And I hope you learned something, especially yung application ng entropy natin. Okay? So I'll see you again next week. Okay? So ingat parate. Although GCQ na tayo ngayon, we should not be complacent because ang Indian variant ay nasa Pilipinas na. Okay, so be careful always and I'll see you again next week. Bye-bye and stay safe.